Okay, so this is section 7.2. It's about graphing absolute value functions. Okay, so this is part 1 of 2 because all videos I make have to be within 15 minutes. Okay, here we go. So part 1. Okay, so first step is how do you graph a line equation? Okay, so first thing is you need to know that all line equations can be written in the form of y equals mx plus b. M is the number or the value that's timesing the value of x, and b is the constant. Okay, so m is your slope. So m is your slope, which is rise over run, and b is your y-intercept. And your y-intercept is where the line crosses the y-axis. Okay, crosses the y-axis. All right, so let's say you have two of these equations. Let's start with this one on the bottom here. Okay, so you see how you have x. There's my variable x. And then there's my y variable, and then 2 over 3 is multiplying x. That means your slope is 2 over 3. So that means that for every 2 you go up, you go right by 3. So go up 2, right 3. Okay? And your y-intercept, which is b, and right now you're adding negative 4, so b is negative 4. So we graph this one, you start off at negative 4, that's your y-intercept, and then you would go up 2, right 3 to get your next point, up 2, right 3 to get next point. Or you can go down 2, left 3, because when you have a slope of 2 over 3, it's the same thing as negative 2 over negative 3. Okay. So after this, you take the points and you connect them, connect the dots, and this is the line equation for the first one. Second one's a little different, okay? You see how the x is in the back and the constant number 3 is in the front? You can actually write this as negative 3 over 2 times x plus 3, okay? Or you can keep it like this. So your slope is negative 3 over 2, and your y-intercept is 3. So you start off your y-intercept. So when it's negative 3 over 2, that means your slope could be down 3 and then right 2, or up 3 and then left 2, okay? So you go down 3, right 2, down 3, right 2, down 3, right 2, or you can go up 3, left 2, and then there's your line, okay? So in this lesson, you need to know how to graph a line equation in the form of y equals mx plus b or any other form. Right. Okay, so graphing absolute value functions. So when you're graphing the absolute value of a function, okay, meaning like you're going to be given a line and then you're going to be asked to graph the absolute value of that line, okay? Just remember this. Any point with a negative y coordinate will become positive, okay? And if the point already has a positive y coordinate, it will stay positive. Okay, so this is the first rule. So what you have over here, this is a line equation. Your slope is 1 and your y-intercept is negative 2. Okay, and then I'm going to take this line and make a table of values with it. Okay, and then what I'm going to do next is I'm going to take the same equation, and instead of graphing the same equation, I'm graphing the absolute value of the function. Okay, so instead of x minus 2, now I want to graph y equals to the absolute value of x minus 2. And what we're going to do is we're going to make a table of values for both of them. And I want you to notice the difference between them, okay? So when x is 0, y is negative 2, 1 is negative 1, 2 is 0. So these are all the values from this table of values is from this equation. And then what you notice is with the other one, you see how this is negative 2? The absolute value of negative 2 becomes positive 2. Okay? So the reason I got 2 here is because when you plug 0 into this equation, y equals to the absolute value of 0 minus 2 is equal to absolute value of negative 2, so that gives you 2. So that becomes positive 2. Okay? And then if you do the next one, when x is 1, you go 1 minus 2 is negative 1, so absolute value of negative 1 gives you positive 1. Okay? So again, you look at the two equations, you compare them. This y coordinate was negative 1 before. Now it becomes positive 1. This y value was 0, now it becomes 0. 1 stays as 1, 2 stays as 2. So basically, if it was a negative y coordinate, it becomes positive, okay? And if it's positive, it stays positive. Another thing is the x values don't change, okay? So remember, only the y coordinates change. The x coordinates will stay the same, okay? So here's an example. This equation here corresponds with this graph. Your slope is negative 3 over 2, and your y-intercept is 3. Now, what I'm going to do next is I want to graph the absolute value of this function, okay? So now you see how I added these absolute value graph. And so what happens is you look at the original blue graph, okay? And what you notice is there's a bunch of points that are underneath the x-axis. So these are the points where the y value is negative. So when you're taking the absolute value of this graph, all these points with a negative y coordinate, so you see how this is like 2.7 comma negative 1. What happens to this point is it actually goes up to 2.7 comma positive 1. Okay, so every single point that you have over here now becomes positive. Okay, so this is negative 1, now it becomes positive 1. This is like negative 3 point something with a y value of negative 2. Now it becomes the same x value but a positive 2 for the y value. And so when you take the absolute value of a straight line, the absolute value of it becomes a V-shaped graph. Okay, simply because all these points are now flipped upside down over the x-axis and it goes on top. Okay, so the absolute value of a straight line is the V-shaped graph. So the center of the graph is at the x-intercept. Okay, so if I want to find the x-intercept, you just make y equals 0. So you go 0 equals to negative 3 over 2x plus 3. I'm going to move this whole thing to the other side, so you get 3 over 2x equals to 3 times both sides by 2, so you get 6, and then divide by 3, so x equals 2. Okay, so the x-intercept is something called an invariant point, and the reason why it's called an invariant point is because it's a point that doesn't change. Okay, but you won't really deal with much in this section about invariant points yet. Okay, it'll be later on in 7.3 and 7.4. Okay, now what you're going to end up with is two sides, the left and the right. Okay, here's the left side and this is the right side. Okay, and then the left side of the equation was the one that actually did not change. So whatever is inside the absolute value graph will be this equation because it didn't get flipped upside down. The right side of the graph is going to be different. It's the one that got flipped upside down. So it used to be down here, now it goes on top. So that means that the equation of this part of the graph is actually going to be the same thing, like you see how everything inside is inside the bracket, but instead in front you stick a negative sign, indicating that that was the point, this is the side of the graph that was flipped upside down. So you're going to be expected to write something called a piecewise function. Okay, and so what the piecewise function is, you have to split the graph into two parts. The left side where x is less than 2, and the right side where x is greater or equal to 2. And so when you usually write a piecewise function, what you would do is you see what's inside the absolute value, negative 3 over 2x plus 3. You rewrite it out, over 2x plus 3. Stick a semicolon, separate them. And what you do next is you ask yourself, so which side was flipped upside down? The left or the right? And the answer was the left side. So what you do is you put a bracket around the right side and you put a negative sign in front, and that's it. And that is your piecewise function. And what it's really saying is when x is less than 2, you use this equation here. And when x is greater or equal to negative 2, you use the bottom equation over here. And that's what it means. Okay, so that is in. All right, let's move on. So next part is this. Okay, so the question goes, hey, graph this function, the absolute value of this line, determine the x and y intercepts, state your domain range, and state your piecewise function. Okay, so if you can, pause it, and then when you're ready to check your answers, press play. Okay, so first step is determine the x and y intercepts. If you want to find your x intercepts, you simply make y equals 0. So you would go, you change, okay, I'll here. You go 0 is equal to 2 over 3x minus 2. You take the negative 2, you move to the left, so you get 2 is equal to 2 over 3x times both sides by 3, so you get 6 equals 2x, and then divide both sides by 2, so 3 is equal to x. So therefore, your x-intercept is 3, 0. So when x is 3, y is 0. Okay, and the next thing is, what's your y-intercept? Your y-intercept is just right over here. So b equals to negative 2. So therefore, negative 2, 0 is your y-intercept. Okay, so negative 2, 0. Okay, and then what I'm going to do now is I'm going to draw this graph. You know the slope is up 2, right 3, so up 2, right 3, or down 2, left 3. So here's my graph. Okay, there's my graph. And what you do next is, okay, so first part A is your x-intercept is 3, 0, and your y-intercept is -2, 0. B goes, what's my domain? Okay, now you're going to have to take the absolute value of this graph. So this part over here is under the x-axis. What's going to happen now, it's going to get flipped upside down. So this point now goes up over here. This point over here, which is -3, -4, becomes -3, +4. So what you end up getting is, here is your absolute value graph. Okay, there's my new graph. Okay? So this V-shaped graph is the graph of y is equal to the absolute value of 2/3x minus 2. Okay. Now you need to find a domain. The domain is x can be all real numbers. Your range is y is greater or equal to 0. Okay. Now C is the hardest. You have to write your piecewise. So when you write your piecewise, you have to do the left side and the right side. The left side is where x is less than 3, and the right side is x is greater or equal to 3. You use 3 because 3 is the x-intercept. Okay? Put down your semicolons, and then what you do next is you write out the equation. -2, 2/3x minus 2. Now you ask, hey, which side was flipped like upside down? Because the side that was flipped is upside down, you need to put a negative sign in front of it. And you notice how it was the left side that was flipped upside down? So therefore you put a negative bracket and you keep the right side alone. And that is it.